Sorry, I was on such a, well, it felt like a good roll to me and I kind of lost it at the end. So here's what I was going to say next. Um, this idea that mass is producing fields, fields overlapping, and those equations that go with it, it matches what we see in the real world. If we had a person standing here, that person would be surrounded by an invisible gravitational field. The gravity field is the direction another mass would be pushed or pulled, another mass would be attracted to that person. If we had a second person standing over here, same logic, the gravitational field around that person would be a bunch of arrows pointing towards that person, representing that another mass would be attracted towards it. The issue with people is they're so light, their mass is so small that their fields aren't very big. If you're standing beside a person, even let's say like a meter or two apart, actually social distancing, let's say you're 2 meters apart. Basically, at 2 meters, your field is so small, it's not overlapping with the other person's gravitational field. If you're 2 meters away from another person, you don't have to worry about that person being gravitationally attracted and falling into you. There may be some other stuff at work there, but no gravity. The fields are too small, they're not overlapping. No overlap, no force, and later we'll get into stored energy. We don't have to worry about that. Let's get rid of this person. What if instead of the person, what if we still got you and you're an astronaut and you're outside of Earth? Not the scale. If this is Earth, Earth is crazy big and heavy. It's got a huge gravitational field. To represent the gravitational field, like we showed before, a bunch of lines pointing towards it to represent that mass close by would be attracted. Since the Earth is so huge, your little field is automatically overlapped with the field of Earth. Because there's an overlap there, you would feel a force and there'd be some energy stored there. If you were farther away from Earth, I don't think I can erase this guy. Oh, I'll fix it up. If you're farther away from Earth, maybe you're way out here, your field is still going to overlap, but the overlap isn't as strong, so the force would be weaker. If you were closer to Earth, the overlap is stronger, so the force would be greater. So as simple as this theory is, it kind of matches what we're seeing. Two little light objects aren't going to have any force of gravity between them. They're too light. They don't have big fields. The fields don't overlap. But if we get bigger objects, the Earth and other objects, or two other big objects, then their fields will overlap. And the more they overlap, the bigger the force.